Okay, welcome back. We've tidied up the mess. We're driving on with the next example, which is the case but of dropping a sphere into the cylinder like I dropped the messy orange in. Okay, so a sphere of radius 4. Let's do a circle here, and I will go R and 4, or R equals 4. So let's put a tick for the data, for the information that's in important numbers that we're going to use as substitution for variables. Okay, it's dropped into a cylinder partly filled with water. So it doesn't matter if it's partly filled. The only thing that matters is it has a radius. It's a different radius. We're going to use a capital letter 8 here. Okay, here the radius here. When the sphere. So what? And now what we're going to do is we're going to just look at this little sphere here. So that little sphere here has a volume equal to pi r squared h, but in this case the 8 can go, capital R, because I'm using capital R here, the 8 can go in here and we get 64, because 8 eighths is 64 pi times h. Okay, and over here we know the radius equals 4, so we have that the volume of the sphere, and they're equal, right, because the amount of volume there is what it went up, just like my coffee moved up a bit when I dropped the lump of orange into it. Okay, so the volume here is according to the, now I have to use the proper formulas for a sphere. Okay, I keep showing it to you, but you have it yourself in your log tables on page 10. The volume of a sphere. So a common mistake would be just to mix up and use the wrong shapes or the wrong solids. I said that wrong. Surface area and volume. Just see, does the word shape appear here? Oh yeah, the word solid appears here of the solid in question. But we didn't like the way the book mixed up those terms, because it's a very key term, and here's our term here, shape. Okay, 2D shape, 3D solid. Okay, so we're 4 over 3 pi r cubed, and r is 4. So that means we have, well, it's the same, this 4 and these 4s are the same. Well, I'll just write it like this first, and then that is equal to 4 to the power of 4 pi over 3. Okay, now we're going to set them equal to each other. Okay, so and I'm going to do a little trick here, but if you call it a trick, it's a pity to call it a trick. 64 is 4 cubed. Okay, it's a cube. Remember, it's a square and a cube. Okay, so that will allow us to cancel some very nice stuff. The pi's will cancel. 3 of the 4's will cancel. Let me write this as 4 times 4 cubed times pi over 3. Now, if you didn't spot this, you just dividing out numbers will give you the exact same thing. Okay, so 4 cubed cancels and pi cancels, and we're left with h equals 4 over 3. So the height here equals 4 over 3, and you stop right there and call it centimeters. That's what you should do. If you want to go to decimal, you're getting into a mess because you've got 0.33333. So we don't want to go there. So the height equals 4/3 of a centimeter. Okay, and then we're on to the questions from the book. Let's do them real quick. So I'm not interested in what we're going to answer the volume and the curved surface area, the A in each case. Okay, so it's a sphere, so it's pi r squared h. And it's the rectangle from the curved surface area, which was 2 pi r for along here and h along here. Okay, so the only thing we need to worry about is r equals 5, h equals 9, and then we'll get 4 answers, one with pi, the exact value, and one with decimal. Okay, so it's v v equals pi by 5 squared, because I've replaced the r with 5, by 9. Okay, we'll do the area down here, so we'll find that exactly. Okay, and what I can do is I can put the numbers at the beginning. 9 by 5 squared. I don't have to, it doesn't matter what way you key it in. You key it in, you get equal to 225 pi. Give that in centimeters cubed. Okay, then you'll do shift equals, and you'll go equals 706.858 dot dot dot. And now we'll do approximately 706.86 centimeters cubed, and we've set our centimeters cubed here. Now we're going into the area formula, so you start subbing it in. I'll just bring it down here as well, just to try and make it clear what I'm doing. So I'm going to go 2 pi, R needs to be replaced with 5, H needs to be replaced with 9. Okay, I'm going to go to my calculator. Now a trick I can do is go back and edit what I had. It's gone now, so I forgot that chance. Not making a big deal of it, it doesn't make any difference, but there was a chance for me to edit what was on my screen. It would have been probably easier. 2 multiplied by shift pi multiplied by 5 multiplied by 9. Then any old mess, and there's no thing. See, you're allowed to say 2 pi without a multiplication, but I don't think it's worth learning off when you cannot do it. I think it's easier just to put in your multiplications all the time, and then you'll always be you'll be enjoying the experience of learning maths. That's the most important thing of all. Okay, now that is in centimeters squared, and it is exact, but I don't need to say that. Shift equals, you could argue that I should be doing approximately here, because I am going to truncate, so we might do approximate on the last two. And again, I'm not trying to confuse you here now or anything, but that I'm entitled to improve myself too. Learning, we're all learning all the time. That's the nature of problem solving. 282.74, okay, centimeters squared and centimeters squared. Okay, that's that question now. Here we're going to say the radius equals 8 and the height equals 24. And we're going to go and structure our answers down along. So formula here. By the way, another thing, and it came up in class today, in terms of which one comes first and all that. Let's say we'll always just put them in the order of A comes first, V comes second. So but I'll put A on the left and V on the right. Now that doesn't matter, but it's just a way of me reducing the amount of cognitive load in number of choices. That's one formula. That's the second volume formula. Let's go along here replacing. So I'm putting in my multiplication symbol because I know the calculator never lets me down once I put that in. Okay, but you know what? I'm going to do a little bit more work here now, and we're going to look at how can we go from one to the other, as we go along. So we've got pi times 8 squared. So we might be turning that 8 into a square. We might be dropping that 2, and we might be going times 24. Okay. So let's start on the left. We have 2 by pi by 8 by, I'll take that out of this picture, it looks a bit ominous, by 24 equals 384 pi. So when they ask you, and I'm not, we're always, remember, we're always answering in terms of pi, and always approximately to 2 decimal places, and so on, because otherwise it's very frustrating, and it takes the fun out of maths. And maths is a pile of fun, as you know. Okay, now I'll come back to that to round it, and I'll do it by just keying it in again. What's more important is I want to turn that 8 into a square, and I want to drop the 2. And his equals. That way I get this answer here, 1536 pi. Okay, now that's there now, so I'll do my shift equals to bring it to a decimal, to bring it to a real number, element of R, real number, 5825.486. Okay, dot, dot, dot is approximately, still think I like when that equals there, because the dot, dot, dot says the exactness is out here. And then I go approximately 4825.49. Okay, centimeters cubed, and back to this. I can very quickly fill that in knowing it's exact. 384, shift middle of your calculator. Much easier to find that than to find a 7. I mean, maybe it's roughly middle up and down if we ignore those two blue ones. But shift equals, otherwise I'm only going to be delayed. 1206.371. I didn't write that properly. 1206.371 dot 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 is equal to 1206.37 is approximately equal to, anyway, that's area. Area is in centimeters squared. Okay, how are we getting on? Super, that's question 1 done. They're going to get faster and faster now, lads. Okay, now they've turned it around, and I want to be very careful when I say the radius. And I want to look again and see, is there any way here in terms of, well, not really. My height is 80 and my radius is 6. So you won't have to show your calculation. You won't have to say 12 over 2 or anything. The thing is, my height equals 80, my radius equals 6, and you know, it's in centimeters consistently. There are going to be questions now with mixed units where we're going to have to decide what units to go in or read the question carefully. Okay, so we have our area formula on the left. Don't just write the expression, write A equals 4 pi. Look, I nearly did it again, silly me. Up here, it's okay. Area equals 2 pi RH. Yeah, I know if you've looked at all the videos, said that's fooled me twice. Sorry. Okay, and we're going to fill in values. 2 pi 6 times 80. Okay, we're going to go to the calculator with that. And here, like, well, I could say to you I'll stop taking out the tables, but that wouldn't be fair either, because until you know the formulas, take out the tables. Okay, so, and make sure you write them down correctly. And you're saying, look who's talking. Okay, so we've that done, we've this done. Now it's time to get this guy calculated, at least in terms of pi. Okay, so I'm going 2 by pi by 6 by 80. Okay, and I'm getting equals 960 pi centimeters squared. Now you can say exact, okay, you know, and sometimes if there's any doubt, but you don't have to now, it's kind of obvious. Okay, and now rather than continue on, I'm going to take advantage of the fact that this is pi times 6 squared times 80, and I'm going to turn the 6 into a square by using my square function. You can do that on any of the 3 calculators, and I delete them 2 times, including the times and the 2. Okay, and I get my exact answer here equals 2880 pi. I'll shift approximate it, and I'll get equals 9047.786 dot dot dot. I know some of you've been writing all these numbers down, especially if there aren't numbers here. They go out and out and out. Don't, there's no need to. Okay, approximately equal to 9047.7, and I get here and I ask myself, do I go up to round up or do I round down and leave it as it is? I round up to, hang on, 9047, that's supposed to be a 7, and now that's supposed to be a 9. Okay, and the units for volume are centimeters cubed, and to me it makes sense that the area is on the left and the volume is on the right, and the units over here are centimeters squared. Oh yeah, now we're going back to do this, so we're just clearing and we're quickly keying in 960 pi. Forgot shift equals. It's okay if you, now you're the SD button as well, same thing, approximately equal to 3015.928, and despite the fact that that next one is a 9, it doesn't matter, is approximately equal to 3015.93. That's centimeters squared. We're going on to the next question. Okay, well, this is, and I don't care, nearest whole number, doesn't matter, we can anyone can do that. Same type of question with skip it, same kind of question with skip it. Oh, it's not the same kind of question, it's the one I'd already just done probably, because I copied this a few times. Now this has no picture, and we're not doing them because they're not coming up anymore in the exam. Okay, so we're just going to use the proper pi. A solid cylinder has a radius 7, so we're missing a picture, so we'll draw a picture. And if you want your inspiration or whatever, you go back to you open up your tables and say, I'm drawing this. And what's great about our picture here is the top ellipse is all drawn in. You draw your sides in, you draw the front, I've talked about the front of the equator for a sphere, and you draw the front, this part of the bottom of the thing, and your back you can't see, so it's broken. You don't have to do that, but it's nice to do it right. Okay, now what can I fill in? Well, I see my H is here on my left. Well, I might fill in the number here. Has a height of 10. And I might fill in my radius here and put the number way up above here so it doesn't get confused. I can see it clearly, because clear viewing is part of universal design for learning, making things easy for ourselves, and that brings down the cognitive load, which is how much your brain is thinking and maybe possibly making mistakes. Okay, so we've then filled in right. We're going to do the usual thing. Now I just want to show you, like in problem solving, we can, a variety might be, look, let's write the area formula on the top like it is here, 2 pi r h, and let's write the volume formula underneath like it is here, which is pi r squared h. Now let's see, could I move across the page and see, could I go 2 times pi times 7 times 10, and I'm critically thinking that's r for radius, that's my radius. Okay, we'll come back to that in a minute. I can go across or down. Pi, I'm going to say times in future after finishing a pi when I'm filling in the substitution. R is 7 times the height is 10. Okay, it's calculator time. Let's use a different calculator just for a bit of variety, and for those who are feeling a bit left out because they have this calculator. Okay, you're not being left out. 2 times shift 7, 2 times shift 7 times 7, that was handy, times 10 equals exactly 140 pi shift. No, I don't want to do shift equals. Hold on, let me check something. If I do shift equals, aha, I just thought of a better thing again. So I didn't have to put that in my calculator. I've done shift equals. Watch this. So now we're going approximately equal to 439.822, which is approximately equal to 439.82 centimeters. I'm on the area squared. Now watch this. This is even better. So equals means it goes back to where it was, and I actually maybe that doesn't even matter. I still have all this on my calculator that I can edit, so I'm deleting it to, and if you like, I'm adding it to in a funny kind of way with the square function. Okay, so now I can check that I've got it from being the area to being the volume. Yes, I have, haven't I? So I do equals 490 pi centimeters cubed, and I'll always know the centimeters squared is at the top of the page and this is at the bottom of the page, equals shift equals. Now don't like it that the shift has gone to there from the tip top left, because tip top left is an easier place to find. But look, it's not really a big problem, is it? 1539.38. Am I going for like that first with my 3 dots, and that's approximately equal to 1539.38. This is centimeters cubed. That's that question done to a very high standard. We're getting full marks for sure on that. Okay, I'll post this and we'll go again with the rest of the questions.